Hi there, Joshua here. Right, so today we're going to be doing sequences. A sequence is just a list of numbers that follow some sort of pattern. That reminds me, when I was at school, my maths teacher said to me, she said, what are the numbers in this sequence getting closer to? She said, what are the numbers in this sequence getting closer to? I said, the edge of the board. So, let's get on with the lesson. Right, so today we're going to be looking at what are called linear sequences. A linear sequence is just a sequence that goes up or down by the same amount each time. So for example, 3, 6, 9, 12. This is a linear sequence because it goes up by 3 each time. Now the numbers in the sequence are called the terms of the sequence. So this is the first term, this is the second term, the third term, this is the fourth term. The reason it's called a linear sequence, by the way, is because if you were to plot it on a graph, the points would lie in a straight line. So, for example, the first term is 3, the second term is 6, the third term is 9, and you can see that the points lie in a straight line. And it's because they go up by the same amount each time. So a linear sequence is just a sequence that goes up or down by the same amount each time. Right, now I've given you the first 4 terms. If I said what's the 10th term, that's actually not too hard because this sequence is basically just the 3 times table. So this is 3 times 1, 3 times 2, 3 times 3, and this term is 3 times 4. So the 10th term is just going to be 3 times 10, it's just 30. The 10th term is just 3 times 10, which is 30. Now what about if I said, let's bring some algebra into it. What if I wanted to know an expression for the term in position n? So in other words, an expression for the nth term. That's just the term in position n, where n could be any number. Well, as I said, the 10th term is 3 times 10, the 30th term is 3 times 30. So an expression for the nth term is just 3 times n, 3 times whatever number n is. And in algebra we don't usually write times because it looks a lot like an x, so we usually just put the number and letters together and we'd write 3n. So the rule for the sequence is that the nth term is just 3n. All that means is to find a term you just do 3 times its position. Remember, n stands for the position of the term, the position number. So for example, to find the 12th term you do 3 times 12, or to find the 7th term you do 3 times 7. That's all it means. Let's do another sequence. Let's do the 8 times table. 8, 16, 24, 32, and so on. So this is the first term, the second term, the third term, and the fourth term. So what would the 10th term of this sequence be? Well, again, it's very similar. It's the 8 times table, so this is 8 times 1. The second term is 8 times 2, and so on. So the 10th term would just be 8 times 10. 8 times 10, which is 80. So the 10th term is 80. Can we write down a rule for the term in position n, a general rule? In other words, an expression for the nth term? Well, as I said, the 10th term is 8 times 10. The 50th term is going to be 8 times 50. So the nth term is just going to be 8 times n. And again, we could write that more concisely. We just write it as 8n. So the nth term is 8n. Again, that just means that to find a term, you just do 8 times its position. So for example, if we wanted the 20th term, let's say, 20th term, you just do 8 times 20. You just do 8 times the n is the position of the term, the position number. So 8 times 20. So what's that? Well, 8 times 2 is 16. So 8 times 20 is 160. So the 20th term would be 160. Right, what about when the sequence isn't a times table? So we're still going to be doing linear sequences. but this sequence is not a times table. 5, 9, 13, 17. So I've given you the first term, the second term, the third term, the fourth term. What's the next term of this sequence? Well, it goes up in 4s each time. So the next term is just 17 plus 4, which is 21. So the fifth term is 21. Now if I said what's the 10th term of this sequence, it's not as easy as the last ones. Not so obvious. You can't just double this number, by the way. It's not 42. There's a quick way of working it out, though. This sequence goes up in 4s, so it's similar to the 4 times table, because that's the times table that goes up in 4s. So I'm going to write the 4 times table above, which is just 4, 8, 12, 16, 20. So you've got the 4 times table in red and our sequence in black. So how much bigger are the numbers in our sequence compared with the 4 times table? Well, if you notice, they're always 1 bigger. You always have to add 1 to get from the red numbers to the black numbers. So that's plus 1. So now we can find the 10th term of our sequence, because the 10th term of the 4 times table is just 40. This 4 times 10. So the 10th term of our sequence, which is we know is 1 bigger than that, is going to be 41. And we can also use this idea to come up with a general formula for the nth term of our sequence. So the term in position n. So an expression for the nth term of the 4 times table is just 4 times n, which is 4n. And the nth term of our sequence, well, the terms of our sequence are always 1 bigger. So the nth term is going to be 1 more than 4n, which is just 4n plus 1. 4n plus 1. Just write that over here. Nth term equals 4n plus 1. And all that's saying is to find a term of our sequence, you just do 4 times its position plus 1. Remember, n just stands for the position number of the term. So for example, if you wanted to know the 15th term of our sequence, you just put 15 into the formula. You just do 4 times 15 plus 1. 4 times 15 is 60. And when you add 1, you get 61. Let's do a couple more sequences. Let's do 7, 12, 17, 22. So I've given you the first 4 terms of this sequence. And let's say we wanted to know the 10th term of this sequence. So we'll do it in the same way we did that one. What you do is you find the times table that the sequence is related to by seeing how much it goes up by each time. So the sequence goes up by 5 each time. So it goes up in 5s. So it's related to the 5 times table. That's the times table that goes up in 5s. So it's very similar to the 5 times table, which I'll write up here in red. 5, 10, 15, 20. And then we'll compare it. So our sequence doesn't start on 5, it starts on 7. Which means that all the numbers in our sequence are 2 higher than the numbers in the 5 times table. If you notice, they're always 2 higher. So to get from the red numbers to the black numbers this time, you have to add 2. So we can now find the 10th term, because the 10th term of the 5 times table is just 5 times 10, which is 50. So the 10th term in our sequence is going to be 2 higher than that, so it's 52. Let's bring a bit of algebra into it. Let's find an expression for the nth term of our sequence. Well, the nth term of the 5 times table is just 5n. So what's the nth term of our sequence going to be? Well, it's just going to be 2 more than that, 5n plus 2. 5n plus 2. You can't simplify this, by the way. It's not the same as 7n. If it was 5n plus 2n, that would be 7n. But 5n plus 2 can't be simplified. I'll just write it down here. Nth term, 5n plus 2. The reason it's 5n plus 2 is because our sequence is 2 higher than the 5 times table. So it's 5n plus 2. And all that's saying is to find a term in our sequence, you just do 5 times its position plus 2. So for example, to find the 30th term, you just do 5 times 30 plus 2. You just put 30 into the formula. 5 times 30 gives you the 30th term of the 5 times table, which is 150. you have to add 2 to get the 30th term of our sequence, which is 152. Let's just do one more example down here. Let's do 2, 8, 14, 20. So again, I've given you the first 4 terms of this sequence, first, second, third, and fourth. Let's say we want to know the nth term formula for this sequence. Again, we see which times table the sequence is related to by seeing how much it goes up by each time, and then we'll compare it with the times table, see how much higher or lower it is. So this sequence, what does it go up by each time? Well, it goes up by 6 each time. It goes up by 6 each time, just like the 6 times table. So it's related to the 6 times table, which I'll write up here in red. 6, 12, 18, 24. But our sequence doesn't start on 6, it starts on 2. So all the numbers in our sequence are 4 lower than the numbers in the 6 times table. If you notice, it's always the black numbers are always 4 lower than the red numbers. So to get from the 6 times table to our sequence, you always have to take away 4 this time. So now we can find the expression for the nth term of our sequence, because the nth term of the 6 times table is just 6n. So what's an expression for the nth term of our sequence? Well, it's going to be 4 lower than 6n, so it's 6n minus 4. I'll just write that over here. Nth term, it's 6n minus 4. And that's because it's just, our sequence is just 4 lower than the 6 times table, basically. So let's find the, 20th term, let's say. 20th term. To do that, you put 20 into the formula. So you do 6 times 20, take away 4. 6 times 20 is 120. And then when you take away 4, you get 116. Right, now, linear sequences can go down by the same amount each time. So let's do one that's going down. Let's try and find an expression for the nth term of one of those sequences. So consider the sequence 5, 2, minus 1, minus 4, minus 7. So here I've given you the first 5 terms, the first term, the second term, the third term, the fourth term, the fifth term. Right, let's say I wanted the 10th term of this sequence. So, it's going down by how much each time? It's going down by 3 each time. So take away 3, take away 3. So basically it's very much like the minus 3 times table, if you can imagine such a thing. So the minus 3 times table would just be minus 3, minus 6, minus 9, minus 12, minus 15, and so on. And then how much higher are the numbers in our sequence compared with the minus 3 times table numbers? Well, to get from minus 3 to 5, you have to actually add 8. You have to add 8 to get from each number, and to get from the red numbers to the black numbers. So the 10th term of the minus 3 times table would just be minus 3 times 10, which is minus 30. So the 10th term of our sequence is 8 higher than that. So you've got to add 8 and it will become less negative. It'll be minus 22. Minus 22. Let's think about what the nth term, an expression for the nth term of our sequence would be. Well, an expression for the nth term of the minus 3 times table is just minus 3 times n. We've got minus 3 times 1, minus 3 times 2, and so on. It would be minus 3n. And our sequence, the numbers in our sequence are always 8 higher. So the term in position n for our sequence would just be minus 3n plus 8. So minus 3n plus 8. You could also write that the other way around. You could write it as 8 minus 3n as well. But I think I'll keep it that way around. The nth term is minus 3n plus 8. And that's just saying to get a term in this sequence, you just do minus 3 times the position plus 8. So for example, to get the 30th term, let's say, 30th term, you just do minus 3 times 30 plus 8. 3 times 30 is 90, so minus 3 times 30 is minus 90. Minus 90. And when you add 8, you're making it less negative, a tiny bit closer to 0. You get minus 82. Minus 82. Right, let's finish off with a slightly harder question now. So I've got a sequence here, 1, 4, 7, 10, 13 and so on. And the question is 763 in the sequence? So in other words, if I carry on far enough, will 763 appear in the sequence? And also, is 1020 in the sequence as well? So what I'm going to do is I'm going to find the nth term formula for the sequence, and that will help me to decide whether these numbers are in the sequence or not. So let's do that. Let's find the nth term formula. So I've given you the first 5 terms of the sequence: first, second, third, fourth and fifth. And the sequence is going up in threes, so very much like the 3 times table. So let's write the 3 times table above. That will help us to find the nth term formula. And of course our sequence doesn't start on 3, it starts on 1. So all the numbers in our sequence are 2 lower than the numbers in the 3 times table. So the nth term formula for our sequence, well, for the 3 times table, the nth term formula is just 3n. So for our sequence, which is 2 lower than that, it's just going to be 3n minus 2. 3n minus 2. So for example, the 10th term of the sequence is just 3 times 10 minus 2. Or the 50th term of the sequence is just 3 times 50 minus 2. Now for 763 to be in this sequence, there'd have to be a position number, a whole number, that you could put into this formula and get the answer 763. But is that possible? Well, let's assume it is possible. Let's assume that 3n minus 2 can be 763. Let's find what that number would have to be. In other words, let's solve the equation to find out what n would have to be to get the answer 763. Now when I solve equations, I do what I call the balance method. That's doing the same thing to both sides to keep them balanced, to keep them equal. So we want to get n on its own. So first thing we can get rid of is the minus 2. Now the inverse of subtracting 2 is adding 2. So you can add 2 to this side. And of course you've got to do the same to the other side as well to keep both sides balanced, to keep both sides equal. Let's just write down what we've got left on each side. So on this side you've just got 3n. On this side you've got 765. So we want to get n on its own. On this side we've now got n times 3, so we have to divide by 3. And of course you've got to do the same to this side as well, divide by 3. So we're left with n on this side, and 765 divided by 3. I don't know that off the top of my head, so let's do that at the side. So 3's into 765. 3's into 7 goes twice, remainder 1. 3's into 16 is 5, remainder 1. And 3's into 15 is 5 exactly. So we get the answer n is 255. So that's telling us that when you put 255 into this formula, you get the answer 763. So it is in the sequence. It's the 255th term of the sequence. So the answer is yes. It's the 255th term of the sequence. If we'd have got a remainder here, or a decimal answer, then we'd have known that it's not in the sequence, because you can only put in whole numbers into this formula, because the position numbers are just whole numbers. But since we've got 255, that tells us that it is in the sequence, it's the 255th term. Right, let's do the same with 1020. So is that in the sequence? In other words, is there a position number, a whole number, that you can put into this formula and get 1020? Again, let's see what n would have to be for this to equal 1020. If the answer is a whole number, then we'll know it is in the sequence. So let's see what happens. So I'm going to solve this equation by doing exactly the same steps. I'm going to add 2 first to get rid of the minus 2. So what we're left with on each side, we've got 3n here, and we've got 1022 here. And now I'm going to divide both sides by 3 to just get n on its own. Divide by 3. So on this side you end up with just n. And again, 1022 divided by 3, I don't know that, so I'll do it at the side. So 3's into 1022. 3's into 1, doesn't go, so I write a 0 up here, and then I just carry the 1. 3's into 10, it goes 3 times remainder 1, so 3 remainder 1. 3's into 12, goes exactly 4 times, no remainder. Then 3's into 2, doesn't go, and there's a 2 as a remainder, so remainder 2. And actually, if you were to continue this as a decimal, the answer would be 340.666 recurring. So if you were to do it as a decimal, so 340.666. So because we got a decimal, because there's a remainder here, that means 1020 is not in the sequence, because you'd have to put a decimal into this formula, but the position numbers can only be whole numbers. So since there's no position number, no whole number that makes 1020, 1020 is not in the sequence. So the answer is no. Right, so that's the end of the lesson. I'm going to put some questions now at the end of the video for anyone who wants a bit of extra practice on what we did today. As I always say, the best way to improve at maths is to watch my videos, obviously, and to answer and to do practice questions as well. I'm going to put the answers after that, so you can pause the video, have a go at the questions, and then look at the answers. And make sure you do the questions first this time. Right, here are the questions. Bye.